Welcome back, dear children. Myself Sir Sunil, your chemistry teacher. How are you all? Fine? Okay students, we are discussing our third units, elements, compounds and mixtures. And we have reached the point mixtures. And nowadays we are discussing how to separate the important components from the mixtures. Yesterday we have discussed filtration, decantation and all. Okay. Now we are going to discuss about the point dissolution and evaporation. So students, you please take out your book and ready to watch this session carefully. So students, here is our topic, dissolution followed by evaporation or crystallization. Okay, before starting our concept today, I am going to ask you one thing. May I ask, did you start to complete your copy work, students? We have completed 2 chapters, okay, don't forget, clear? And also I have given the question answers to you in NLP platform, in PDF form, okay? You go through it and start to complete your copy work. When the school starts, your workload that will be less. Okay students. So now we are going to start our session today by the topic dissolution followed by evaporation or crystallization. This method is useful for a solid mixture of which one component is soluble in a chosen solvent but the other is not. This method is useful for a solid mixture of which one component is soluble. Clear? In those type of mixture, one component will be soluble and other is not. Example, mixture containing salt or sugar and sand. Salt or sugar, one of it. Clear? It can be salt. Then we can consider salt and sand. Or chalk or sawdust, or sulfur and iron filings. To separate like this solution or like this mixtures, we are using this method, dissolution followed by evaporation or crystallization. Clear students? In salt or sugar case, salt or sugar or sand. In this case, salt and sugar is soluble, but sand is not soluble. Then in this type of method, what to do? Stir a salt and sand mixture. We are considering salt and sand mixture here. Stir salt and sand mixture in water and warm so that the salt dissolves. Just mix salt and sand. Clear? And keep this mixture in water and stir it and warm. Why we are heating it? The dissolving process should be fast. That's why. And then filter the mixture. Filter by using the filter paper. Just filter the mixture. What will happen? The salt passes into the filtrate and the sand remains as residue. The sand will be remains in the filter paper itself and the salt will pass through the filter paper and will be collected in the beaker. The residue is washed with warm water to make the sand free of salt. Clear? The residue is washed with warm water to make the sand free of salt. Residue which we are getting sand. Here is a residue is a sand. That sand can be washed. Clear? For what? To get it sand free. Clear? Sorry, to get it salt free. Okay students. Then the filtrate along with the washings. Okay, the filtrate what we are getting down there in the beaker means salt solution. By washing the residue, we are getting some more solution also. Okay. So, the filtrate along with the washings is slowly heated in a china dish when the water evaporates and the salt is left behind. Till the end of the water, we have to heat the solution which we got as a filtrate. Till the end of the solution, just we have to heat it. Then what will be remains back there? The salt will be remain back. Okay, students, this is the process. A purer sample of the salt can be obtained by crystallization from the filtrate. After this process, we'll get a pure sample of the salt that can be obtained by crystallization from the filtrate. The filtrate is heated to obtain a concentrated solution. That means a solution containing a smaller proportion of the solvent than usual. When the concentrated solution is left to cool slowly, the white crystals of the salt separate. Remember that a purer solid is obtained from a solution by crystallization rather than by evaporation to dryness. Crystallization sets in better and faster if the concentrated solution is seeded with a small crystal of the pure solid. For seeding, you may simply have to add the solid to the concentrated solution while cooling. You have learned the previous class how crystals of candy can be obtained from a concentrated solution of sugar. In 7th class, we have discussed. Here you can try to obtain crystals of copper second sulfate pentahydrate. You please mark the chemical formula CuSO4.5H2O, also called the blue vitriol. Another name of copper sulfate pentahydrate is blue vitriol. Please mark it. Okay, students. Now we can have one activity or experiment here. Prepare a concentrated solution of copper second sulfate in a beaker by dissolving as much of the salt as possible. First of all, you have to prepare a concentrated solution. Then heat this mixture occasionally to dissolve more and more salt. We have to heat it. We have discussed there to make the solution process. To make the solution process fast, what to do? We have to heat it. Filter and evaporate the solution in a basin till a crust is observed at the surface of the liquid. Stop the heating and allow solution to cool. Allow this solution to cool, this concentrated solution to cool. And what will get back? We will get the crystals of blue vitriol. Clear? Blue crystals of copper sulfate pentahydrate will appear slowly. Clear? And this size will grow in size with time. Okay, it will grow in size with a time. Within a short time, it will this size will change. Okay, this is the diagram. Okay, crystallization of copper sulfate pentahydrate. Okay, first we have to make the solution. Then we have to pour the solution in a china dish. Okay, then heat it by the burner. Clear? At last we will get the crystals of copper sulfate pentahydrate here. Similarly, sulfur can be separated from iron filings by stirring the mixture with the carbon disulfide. The sulfur comes out with the solvent. In this experiment, the sulfur comes out with the solvent. Iron is filtered out and the filtrate gives sulfur on evaporation or crystallization. Okay, students, in many of the experiments we can do this process to separate it. Okay, now we are going to discuss the distillation process. By distillation, we can separate a solid liquid mixture. By distillation process, we can separate the solid liquid. A solid liquid mixture means homogeneous mixture. Example, Example, a solution of salt in water. A solution of salt in water. Or heterogeneous mixture like a sand and water or chalk water mixture. A heterogeneous mixture like sand and water or chalk and water mixture can be separated by the method distillation. The apparatus is that we are going to do the distillation process here. Okay, this is a diagram. Let's go through the diagram before the discussion. Okay, how the apparatus are arranged, how the arrangement how to be done for the distillation process. This diagram, this is the diagram. This diagram is your holiday homework. Okay, you have to draw in a drawing sheet and keep it in a file. Okay students, this is holiday homework. This diagrams can expect in half-yearly exams and unit test and all. Please draw it. Okay, it's very important diagram. And arrangement also you have to observe now. The discussion is coming now, so you have to observe it carefully. Now what to do? The diagram already we have seen. Okay, the apparatus is set up as shown in figure, which we have seen now. The mixture is boiled in a distillation flask. The mixture is boiled in a distillation flask. Here it is, distillation flask. Okay, the mixture should be boiled in a distillation flask. And here is one thermometer is kept. Okay, while it boils, it shows the 100 degrees Celsius. Okay, means it changes to the liquid content will changes to gas. Okay students, and this gas will pass through the Liebig condenser. Okay, the gas which is formed, that pass through the Liebig condenser. See, there is a distance from here to here. While this gas pass through Liebig condenser, what will happen? This gas will cool and will changes to liquid. Okay students, it will changes to liquid. Then that liquid will be collected in the receiver. There is a flask, one more flask is kept there. Here the liquid will be collected. Okay students, so we are going to discuss now the activity here. So apparatus is kept there. Just in a short we have discussed. Okay, by boiling the mixture in distillation flask, what will happen? The vapors comes out. And condense while passing through that vapors will condense by passing through the Liebig condenser, I told you, in which they are cooled by the water circulating in the outer jacket. The pure liquid that will be collected, in the receiver. The solid soluble or insoluble remains in the distillation flask itself. The solid which remains in the distillation flask itself. Okay students, this is the activity. This is how distilled water is prepared in the laboratory. Okay students, now we are going to discuss the fractional distillation process. This diagram also very important for you. Please observe the diagram, and this is also your holiday homework diagram. Okay, holiday homework diagram. Okay students, it is also homework for you. You please draw this one in another drawing sheet and keep it in a file. Okay students, you know very well, last year I have already taught you the formalities, how to prepare the files and all. Okay students, those who know, you have to say to other students, your friends, okay, how to prepare. Okay students, this is your homework. Okay, so please observe the diagram, how we are going to do the fractional distillation. Okay students, fractional distillation. Okay, now we are going to start the discussion about the fractional distillation process. By fractional distillation, what we are going to do? We can separate liquids which differ in their boiling points by 20 degrees Celsius and more. We can separate the liquid, clear? We can separate the liquid which have the boiling points by 20 degrees Celsius or more. Okay, students. So here the diagram you have already observed. The liquid mixture is boiled. First we are going to boil the liquid mixture in the distillation flask. Distillation flask is here, okay? Distillation flask is here. This one is a distillation flask. We are going to boil it. We are going to boil the mixture in the distillation flask. What will happen to it? It will change to gas or vapor. Or vapor. It will change into gas or vapor. Okay? Okay, students. And here, what is the difference between distillation and fractional distillation? Here we are keeping the mixture of different types of liquid. The liquid mixture, here we are considering the liquid mixture, not a solid liquid mixture and all, only liquid mixture. In this liquid, there are different types of liquids which have the boiling points different boiling points. Okay, while we boil the liquid mixture in the distillation flask, fitted the fractionating column and a Liebig condenser. Okay, Liebig condenser. The mixed vapors enter in the fractionating column. The mixed vapors enter in the fractionating column where the vapors of the higher boiling point liquid condense and trickle back into distillation flask. The vapors of the lower boiling point liquid, however, pass into the Liebig condenser where they condense. The liquid is collected in the receiver. The lower boiling point, that also will pass through the Liebig condenser and will be collected in the beaker, and we have to remove from there and aside and keep this one that in a side, and we have to collect new beaker for next liquid. Clear? The temperature of the boiling mixture remains constant till the lower boiling point liquid distills completely. Clear? First, the lower boiling point liquid will be collected in the separate beaker. You can go through the diagram once again. Okay, once again you can go through the diagram. Okay, suppose that the lower boiling point 1 liquid is vaporized. So what will happen to it? It will pass through the fractionating column, clear, fractionating column, and pass through the Liebig condenser and will condense here. It will cool, it will get cool and condense here, and it will change as liquid. Okay, students, and it will be collected in the receiver. Then once that particular liquid is collected, what we have to do? We have to change this receiver and keep the receiver aside and keep a new receiver to collect next liquid. Okay, students. So the temperature of the boiling mixture remains constant till the lower boiling liquid distills completely. Then the temperature again rises till the higher boiling liquid starts distilling. Then after completing this distillation of the lower boiling point 1, the higher boiling point liquid will start distilling. The receiver is quickly changed to collect the higher boiling point 1. The receiver quickly changed to collect the higher boiling point liquid. The liquids obtained by boiling a mixture at different temperatures are called fractions. The liquids obtained by boiling a mixture of different temperatures are called fractions, and the method is called fractional distillation is fractionation. Okay, fractionation, and the method of fractional distillation is also called fractionation. By this method we can separate benzene. The boiling point of benzene is 80 degrees Celsius from toluene. Benzene from toluene. Ethyl alcohol from water. The boiling point of ethyl alcohol is 78 degrees Celsius and water is 100 degrees Celsius. We know that. And petrol, diesel, kerosene from crude oil. To prepare to distill the petrol, diesel and kerosene and all, we are using this method, fractional distillation. Okay students, now the time is too much today. Okay students, so today we are going to wind up this class, time is up. Okay, so whatever doubts are there from this topic, you can ask me directly when class starts. When you are reading, you will get the doubts. If you are reading only, you will get the doubts. Okay students, you have to read the chapter 2 or 3 times, then only you will get the doubts. 2 types of students are there. If you are not getting doubts, maybe you understood all the topic. Otherwise, you are not revising the topic. Those who are revising the topic, they will definitely get doubts. Okay, that can be clarified in the class itself when class starts. Okay students, so today I am going to wind up my section. Goodbye and have a nice day.